My name is Karthik, and I'm the TA for the CSE 404 for the winter term. So welcome everyone to the class. My background is I'm a PhD student in the Department of Computer Science, and I work on research in human-computer interaction and human-robot interaction. And in terms of my experience with Unity, I've been using it for almost 4 years now, mostly for doing research projects and building prototypes, but I have built some games as well on the side. And I'm hoping that my experience so far can be of use to people here. And so as Steve mentioned, I've recorded a series of tutorials on YouTube, just introducing you to the concept of Unity. Before I jump into the details, I just want to get maybe from the chat, has anyone had a chance to look at these videos yet, or has anyone have any experience with Unity? Just want to get a sense of like what the experience levels are like. Okay, perfect. So it looks like several of you have at least a little bit of experience. Even if you don't, it's not a problem. The only thing is that some of the things I'll mention in this tutorial or the next 20, 30 minutes may not fully make sense to you right away, but once you watch the videos, it will. But yeah, so I'll just just kind of explain what's going on in this channel. So there's a bunch of playlists that I've created. Some of them I've created. I think some of them have been created by the OCAD groups as well. But the main one is the custom set of tutorials that I've put together, which is this one. So this is the Unity tutorials playlist. And there's a set of videos that kind of introduce you to building like a very simple game. I've also collected a few other kind of playlists of videos that I think might be useful. So things like, programming in Unity, programming practices, so what kind of design patterns you might want to use when you're writing code. Things like, if you want to do specific things like building shaders for graphics purposes, maybe you want to build a multiplayer game, so on and so forth. So these are kind of experimental. So if you have any specific areas that you want to explore and you want some help on, please let me know and I can add those as like playlists or add more videos to those specific playlists. So what I'll do right now is I'll just I won't go through the videos per se. I'm just going to kind of explain roughly what's happening in the videos, even if the content is not going to be covered right now. So the first video is basically just introducing you to the Unity Workspace. So how you might want to create a project. What does your scene look like? What does your workspace itself look like? So there's like fundamental things like, there's a hierarchy window, which is on the, one side of the screen here. So on this video for me, it's on the left side, so the top left side. And this is where you're kind of populating all your game objects to prepare your scenes. And then on the, I think, let's see if I can pull this up. Yeah, so on the right side here is the inspector. So whenever you add objects to your scene, each of these has like individual components, which you can visualize by looking at the right side. And then on the bottom, you have your files that you create. So things like scripts and other assets that you can import into the game. So these are like just a high level overview of like what's going on in the video. So if you want to get details, you'd want to watch the video, of course. One thing that I don't think I've mentioned, or maybe I've mentioned in the video, is this idea of like putting scenes in parallel. So sometimes, so basically what I'm going to do is I'm going to sprinkle some tips into each of these videos that may not be covered in the videos themselves. So maybe they'll be of use to you. So for example, the first one I want to mention is like if you're in a workspace and let's say you want to compare two scenes. So maybe you're putting together two scenes. One of the challenges when you're putting together multiple scenes is you want to, make sure that assets between the scenes can potentially be copied over. So let's say you're making two levels that are maybe identical or almost similar, but there's some changes. You may want to edit them simultaneously. So by default, when you click a scene, you can open that scene up. But if you want to modify multiple scenes at once, you can, in theory, just open two of them at the same time. So let's say I've opened this first scene. Maybe I want to open the second scene in parallel. So what I can do is right click it and click open scene additive. And then I actually have both my scenes available to me. And one simple thing you can do then is like you can drag assets between different scenes. So this is just a simple tip that might be useful if you're once you're building out your levels. So just want to mention that. Okay, so then maybe I'll go on to the next video. And along the way, if you have any questions, please feel free to ask in the chat and I'll do my best to answer. Cool. So the second video is basically about how you create game objects and how you manipulate them. There's a bunch of details in here, but I think the main thing which will be super important as you develop your games is this idea of prefabs. So prefab is basically just a collection of, assets and components that you can put together in Unity. So I think here what I do is I'm showing an example of me building a block with a bunch of little components in them. And I also add a script to make this block programmatic. So for example, maybe this is a platform in your game and you want this platform to move up and down, for example, in some sort of programmatic manner. So you can create a game object and then you can create a script and then you can just attach that script directly to the object. And then later on, so I think I do this right now. So I've added a script at the bottom right here. And this is a script that I've created. And then I can add whatever elements I want to the script. And then I create this prefab, which is basically by dragging this object from my scene into my project folder. And now I have this prefab that I can reuse throughout my levels. So this can be used for things like, maybe you're making enemy characters with specific properties. Maybe you're trying to create scenes, or maybe you're trying to create your main characters. So prefabs are really powerful, and I can show an example of like how I've used it myself. So this is a project in which I'm building like a VR, like a interior design tool, basically. And so here's a prefab that I built for the VR player. So I call it XR Rig Offline. And you'll see that it consists of a lot of different things. So it has a camera, which is like what the user can see, the controllers themselves, the left and right controllers, and there's a bunch of individual components that are attached to each of these. So for example, let me see if I can show this. So if you see, when I click the object, there's a lot of components here. Mostly they're scripts because I've added different functionality to this VR controller. So these could be things like, the actual headset and keeping track of the camera or the controllers. It could be more complex things like, maybe I want to manage my tool. So my interior design tool has a couple of different elements. Like for example, the height of an object that I'm trying to build, or how much time I need to hold an object in order to move it from one place to another. So the idea is that you can make really complex prefabs or objects, and then later on, you can just either place them in your scenes manually like this, or you can just spawn them programmatically using a script. So one thing to mention for sure is prefabs are super useful, and you should definitely use them in your games. Okay. Another thing that is useful, generally speaking, when you're organizing your scenes, is this idea of like parenting objects. So let's say you're building a scene with, I don't know, let's say 50 enemies or something. And let's say this cube is your enemy, right? So if I just have this cube in my hierarchy, I can duplicate this many, many times. And now I have a very cluttered hierarchy. So one simple way to manage your kind of scenes or hierarchies is you can parent everything. So you can create like an empty object, for example, and call it the parent. And then you can just drag all your objects into this parent. And now it's very clean. And this is something I'm doing manually, but you can also do this in script. So you can spawn like an empty object, and then you can set the individual objects as children of this main object using script. So this is just a simple tip that can help you organize your scenes. One more thing to note is that typically when you're loading a prefab, you would have to reference this in script. So for example, let's say I make a custom script right now. And let's say it's a public game object, custom prefab or something. And let's say I add this to my inspector or to my scene. So let's say I have an empty object and I add this new script into my scene. You'll see that this object is empty. So often if you want to be able to use this object and spawn it in the scene, you'd have to have some reference to it. So you'd have to drag, like, let's say my prefab is this cube. Where's my cube? Actually, let's just say it's this thing, the stove. So I add this, sorry. Yeah, so let's say I add the stove into this. So this is the way that I would now have reference to this object, and I can spawn it in the code. But another way to do this is you can actually use this folder called resources. So in your project folder, you can create a folder called resources, and then you can just drag your objects into this or into specific folders. And then later on, you don't actually need a reference to this. You can just do something like resources.load, which I do quite often in my script. Let's see if I can find an example of this. Yeah, so here's an example of basically doing resources.load and the name of the prefab that you've called it. So now you don't need a reference to it. You can just find it in your folders. So it's just a simple way to kind of manage things. Okay, So on to the next video. So this video is just about scripting to move objects. So there's kind of two ways in which you can move objects in Unity. One is using physics and one is without physics. The way that you'd use this is kind of dependent on how you want to build your game. So some games are physics-based. In those cases, you'd want to apply forces. And I kind of explore both of these in the tutorial videos. So physics-based is one way to do this. So you add forces to objects in order to move them around. The other options, you just modify the transforms of the objects themselves to move them in the space. And you can do that in code as well. Some of the specific things that I think might be useful is, for instance, you want to add components to, let's say, a game object. There's kind of multiple ways in which you can do this. The first way is that if you have an object in your scene, you can use the add component functionality once you've selected the object, and then you can add your specific components, either by typing the name of the component or finding it in this kind of menu. The other options, you can actually do this in code. So you can do something like add component, which again, I think I've done quite a few times. So maybe I'll find an example of this. Yeah, so here's an example where if I want to add a specific component that I've created, it could be a script, or it could be an actual object or a component like a rigid body. You can just use this add component call to add this to your game object. So these are both two ways in which you can add components. Another thing that I want to mention about scripting is that custom classes are super helpful. And I use custom classes a lot in my own code. So custom classes could be, let's see if I can find an example of this. If I have one. But yeah, the idea is that you can create as many classes as you want, and they don't just have to be mono-behavior classes. So mono-behavior classes are like the standard classes that you make in Unity. So they give you access to specific function calls like start and update. But you can also create data classes which don't require mono-behavior as an inheritance, and then you can just create data classes. So for example, if you're building a game with specific properties for a character, like, what items are they holding, what's their health, and so on and so forth. You can just create custom classes like without the mono behavior, and you can add these properties in here. And then later on, you can just like invoke those instances and use them to manage like the state of your game or the state of your characters. Okay, so yeah, so another thing to mention in this video is I think I've covered, in the video I covered like the old input system, which is like the standard way that people used to do things. So that was like input.getAccess. So let's say you're using a controller or keyboard. You could just pull the raw data of that input device using this function call. But since the videos were made, I've started using the new input system. So it's quite powerful. So it's an event-driven approach as opposed to looking for specific device values. So the idea here is that you can do things like, let me see if I can find an example of me doing this. One second. Yeah. So here's an example where, so if I go to my scene, you can use basically what are called action maps. And so you can, let's say you're creating a game with, let's say movement action maps and also specific character action maps. So you can create specific action maps and assign actions to them. So it's no longer about the specific button that you need to press, but you can create an action, give it a name, and then you can have different ways of triggering the action. So for example, let's say I'm controlling this. So this is an example of a robot. So let's say I'm controlling a robot using the left stick. So I can create a custom action called x-axis, and I actually get the information using the left stick. And in the future, it doesn't matter if I'm using an Xbox controller, a keyboard, or whatever the case is, I can just add these to this action. And later on, no matter what input device you're using, it's just able to pull the information from the action as opposed to the specific device. So this will make your code a lot easier as you begin developing your games for more than one device. Let's say you're building it for keyboard and controller, which is typically what you'll end up doing. Okay. What else? Oh yeah, so one more thing that's kind of important, and I mentioned this, is the order of execution in Unity. So this is a really important document. So this is kind of describing what is the flow of a mono behavior script that you're building in Unity. So by default, when you create a mono behavior, you get two two functions built in, the start and the update. So start runs the first time you start the game, and then the update, which happens later on. I believe it's here, yeah. So this is the game logic. So this runs every frame. And there's a lot of other ones that that are inherited, but you don't actually often use them, but you can. So for example, awake is one where, let's say you're writing a script and you want to establish specific variables before using them in the start. You can use awake to kind of set up everything, and then you start later on. So this is really important because as you build your games out, you want to have a specific order of execution for different properties in the game or different functionalities. So you'd want to make sure that you understand this order of operations while you're doing so. Cool. What else? Yeah, so let's go back to the videos actually. Sorry. Yeah, so the next video I think was about physics, which I haven't covered here, but the idea is that you can move objects using physics or modifying the actual transform of the object. It's up to you which one you'd like to use, and it depends on the type of game you're building. Physics-based approaches is much more complex, but usually you get better results as well. One thing to know about physics is that if you are applying physics-based kind of rules, you'd want to use the fixed update function, which is in that execution order document that I just showed. So you would use fixed update instead of update if you're doing physics-based kind of calls. The other thing to note about physics is that depending on what type of, there's a matrix that you can utilize in Unity. So let's see if I can find this. Yeah, so if you are using rigid bodies versus if you're using like a kinematic rigid body, or versus if you're using a trigger, there's different kind of properties that you want to keep track of. So let's say you're using physics-based collisions. Then let's say one of your objects is rigid body and the other one's also rigid body. Then you would get a collision message. So you would need to use things like on collision enter, on collision exit to get information about collisions that happen. Versus if you are not using physics and not using rigid bodies. So let's say you're using like a static collider. So if I'm in Unity and let's say I create a custom object and I add a collider to this, say a box collider. And let's say make another object. And this one is also a box collider. So both of these are not rigid bodies, in which case, if I go back to this matrix, I would use the static colliders with the static colliders, which means that you wouldn't actually be able to detect a collision here. So if one of these is a rigid body and one of these is a static collider, then you can detect the collision using a trigger. So basically you'd want to keep track of like what objects you're trying to determine collisions between in order to apply either a on collision or an on trigger kind of approach to detect those collisions. Hopefully this will make sense to you as you like build up your game. This may not make sense right away. Okay. I guess the next thing is about, let's go back to the video. Yeah. So this one's about the collision. So I just mentioned this one. So if you are trying to determine when, let's say, a user or a player has collided with a coin in order to give them points, then depending on whether this is a rigid body or if it's just a static collider, in this case, I think it's static, then you would use either a collision or a trigger to determine that. And I think in this case, I use collision to detect because my character is a rigid body. Okay. So the next one is about spawning prefabs, which I've already kind of mentioned before. So the next video is about keeping track of the player's information. So here, I kind of briefly mentioned this idea of like custom classes. So you can use custom classes or just variables to keep track of player information, but depending on how complex your game gets, you'd probably want to build classes for just keeping track of data. And so here, I think I mentioned the idea of like using finding versus getting components. So, sometimes you want to find an object by name, in which case you can use a call like GameObject.find. Typically, you want to avoid using that because if your object name changes, then if you don't have a way of dealing with the changes, then you're going to have errors in your code. So there's better ways to do this. So things like getting collisions, or getting components rather, is a way that you would avoid some of these issues, because now you're kind of capturing or getting components as opposed to getting game objects by the name itself. So I think I cover that information in this video. And then I think the last one was about game UI, which here I think I cover it using using the standard input system as well. I think one thing that I have kind of learned since then is like there are better approaches to get event information from UI. So one example of this is in my current project where I have this UI, let's say, if I can pull this up. So I have this UI that the user can press on. So for example, I want to plan or execute or delete an action or delete a robot trajectory. So let's say I want to plan something. I can click on the plan button and I'm basically calling a function to plan something for me. So there's many ways in which you can detect this information, but let's see if I can find the exact. Yeah, so let's say I have the save button. So let's say the user wants to save something. I have a script that's attached to this button. And the typical way that you would use this is you would just, for an on click, you can just put a function that would be called when you click the button. But a better way potentially of doing this is that you can actually use interfaces that Unity provides for the UI. So for example, here I'm using the iSubmit handler, which is an interface that gives you information about, when the user clicks a button, the system will automatically detect it, and you can actually use this information. And there's a lot of different there's an iSelect, there's an iSubmit, there's a lot of different interfaces that you can use. But the idea is that here, you don't have to keep, you can keep your logic for individual buttons within custom classes, and then you can handle them separately. So for example, if a user clicks this button, then I can invoke a custom event. And then whatever function subscribed to this event will get this information, and then I can do something with that. So for example, if I see what's happening here, so there's a specific function that's listening for this event. And then if this button is pressed, then this specific function will run. And there's something in the code here, of course, about that. So this is like an event-based approach to programming, which I think can be useful, especially when you're building complex games. So that's just something to consider. And then I think the last two videos are about animation, which is if you wanted to do animations in Unity, you may want to use this, but I think for the most part, you'll have an animation, like people who are actually doing the animations for you, so you don't have to worry about building the animations inside of Unity. Instead, you'll probably want to worry about like importing these properly, so importing custom models, which will be coming from the art teams, and also importing animations that are coming from the animations teams, and importing them properly so that you can apply them to your specific games. Okay. So the other thing I want to kind of mention is some material. So I'll share this with the group on Zoom. Okay. So essentially, this is just a kind of a curated list of a couple of different kind of, or a set of different things. So basically, all the way from programming to best practices of Unity. So I definitely recommend if you have a chance to at least look at this, please do so. The basic stuff is, since I have 5 minutes, I'll cover some of these. So the first thing to note is that Unity Pro is this like service that is free for everyone. If you're a student, and I would recommend downloading Unity Pro, which is, in addition to just providing this like black theme, it also has a lot of powerful things like metrics for your games. So if you're, let's say you're writing code for something and you're seeing that it's slowing down, you can actually run, analytics on your games. So you can actually go through, and figure out, what is the bottleneck to my code? Is it a specific function? Is it the physics? Is it the simulation? Or is it the animation, or whatever the case is? So you can kind of very carefully troubleshoot your game using this approach. So I would definitely recommend, if everyone can, please install Unity Pro. It's free for students, as I mentioned. It has some additional things like, lessons to get you familiar with Unity. For those who don't have much experience with it, you can potentially go through this if you don't want to look at those videos. There are other approaches to learn Unity. I cover, I think, a set of assets that might be useful for you as you're developing your game. This will depend on what is acceptable. So not everything here will be acceptable for this course, but some of these might be. So for example, if you're building a multiplayer game and you're troubleshooting it by yourself, you don't have access to another machine, you can use this asset called ParaSync, which lets you create multiple instances of your game locally. And you can kind of mimic playing a multiplayer amongst yourself, just by yourself on the same machine. So that's just one cool asset that lets you troubleshoot your multiplayer games, for example. There's this asset called Cinemachine, which lets you build kind of cool cameras, which will save you some of the trouble of building your own camera sometimes. So this is something to consider. Outside of the assets themselves, there's a lot of different resources to learn how to program in Unity. So there's a book called Unity in Action, which is a really good book. So this is more about the engine, so not necessarily C#. So if you want to get into C#, there's other books for that as well. Definitely when you write complex games, you're going to have a lot of code in your games. And so spaghetti code will become something that you want to avoid. So using programming patterns will kind of help you avoid some of those obstacles. So I definitely recommend maybe going through like the free resources like the GitHub link here, which covers some of the basic patterns and how you might use them. There's one that's more programming language agnostic. So if you want to just go through and understand the patterns themselves without knowing about what the implementation is, you can also use this free book. The other one is just videos of, again, people showing how to use Unity. There's documentation support. So the Unity documentation is reasonably good, I would say. So depending on what you're looking for, you can pretty much find everything here. So if you have questions about how to use a specific function, you can use the documentation to find information about that. The next thing is the IDE. So I personally use Writer because I find Writer is a really powerful tool, another free tool if you're a student. So definitely recommend downloading Writer. But if you don't want it's kind of heavy on the resources. So if you don't want to use that, you can always use VS Code or Visual Studio, which is like the standard one that people use as well. Another thing to be familiar with is debugging, of course, because in your 3D games, you don't just want to have debug statements everywhere to figure out what's going on with your game. So learning how to debug a 3D game in Unity is super helpful because you can avoid a lot of bottlenecks doing that. The final one, I guess, that's kind of important is setting up Git. So definitely you want to make sure that you're using Git properly because if you're working as a team, you want to avoid issues of like multiple people working on the same thing and losing some of the changes that you're making. So definitely you want to set up Git properly, and there's a lot of resources here on how to set it up and how to set up the Git ignore, which is probably the most important thing, which is making sure that you're uploading the right information and you're not actually uploading the entire file itself. Like let's say you're importing a huge 3D model, you don't want to make that, you don't want to track that as opposed to the code itself. So definitely have a look at this and try to use this one, for example, in your, at least at the start, and as things come along, you can add more things to your Git ignore. Yeah, I think that's kind of roughly what I wanted to cover. At this point, if you have any questions, I'd be happy to take them.
I think everyone's done. It's like,
perfect.
Yeah, this is a lot, right? Well, I mean, okay, so there's one question about how to commit assets. Before we get to that, what I'm going to do is I'm actually going to stop the recording soon, and you can continue with asking a few questions if you'd like. But I just want to say we're very lucky to have Karthik here because he's been the TA for the course since, oh gosh, I guess since we went online, last year. So this is his 4th time TAing it, and yeah, he'll be an invaluable resource for those of you who are having troubles or questions about Unity. I would suggest, yeah, go to Karthik, and he'll be able to help you out. With that in mind, I'm going to stop recording, and if you want to we can stick around and ask a few more questions. But hopefully this will be helpful for those of you who weren't able to make it and are watching the recording at the moment.